Hello, my name's Mohammed Rajab. I'm a software developer at LD Talent. So welcome to the screencast demo of simulating the Flappy Bird game in Gazebo. So in this project, we aim to enhance our skills with the Gazebo simulator by building a simple and yet fun game. So let's dive in. So first, we start by setting up the project in Gazebo. So use a box to represent the bird and vertical columns as obstacles. So by pausing the Gazebo world, we can toggle physics on and off to better understand our surroundings. So on to the next step, we try to configure the flying mechanics. So we incorporate a Gazebo force sensor to provide a wing flapping motion. Now we also use the Python library called the pynput to control the force upon key press and release. So this allows us to control the bird's movement using the arrow keys, as you can see from the video. We also, to enable continuous forward horizontal motion, we also add the Gazebo Planar plugin. So this allows movement along the x-axis and y-axis. We always apply a constant velocity in the direction of the project. As you can see from the video, applying a constant velocity through the Planar plugin while flying. So on to the next step. Moving on to the spawning obstacles, we randomize the heights within certain limits. So we stack the pipes with consistent offset to ensure that they're evenly spaced. We also try to handle the collisions at dynamic spawning. So when the robot collides with an obstacle, it responds at the origin and all deployed columns are related. So as you can see from the video, the range is minimized to show the pronounced effect of column spawning. And for the column, when columns are deleted, the box responds once collision is detected. So moving on, to follow the model using the Gazebo camera, we initially try the built-in follow feature, but it has its own limitations. As you can see from the video, using the follow feature of Gazebo to keep track of the box. So we try to use the visual plugin template provided by Gazebo, which allows us to directly access the Gazebo camera and provide a smoother experience. As you can see from the video, we're trying to use the visual plugin template provided by the Gazebo. So as you can see, it provides a smoother experience. Next, we try to enhance the visuals of the game. So we replace the box and columns with the actually Flappy Bird model and pipes from the game assets. And also we try to adjust the origin, orientation, and lighting of the models to improve the appearance. We also try to spawn a background with a custom texture to mimic the Flappy Bird gameplay. So throughout the project, we try to utilize various learning tools, such as pynput for capturing key presses, Gazebo plugins for collision monitoring and controlling flight, and Blender for visual enhancements. So these tools helps us to develop our skills and overcome challenges. So in conclusion, simulating the Flappy Bird game is a great way to improve your skills with the simulator. You can also find all the code and resources in our GitHub repository at Flappy Bird Gazebo. If you have any questions or would like to learn more about Gazebo or our ROS, please feel free to comment on the blog post or raise issues in the repository. Your feedback and feature requests are always welcome. Thank you for joining us in this screencast demo. Happy coding and have fun simulating the Flappy Bird in Gazebo. Thank you.